Hello everyone, welcome to this channel of Easy Study of Food Technology and Engineering. Today's topic is gram staining and serial dilution. It is a part of the food microbiology syllabus of your GATE syllabus. So, what is gram staining? Gram staining is a method of determining the type of bacteria, like whether it is gram positive or gram negative bacteria. And why is it done? It is done because the gram positive bacteria um, are what you say less resistant to antibiotics, whereas the gram-negative bacteria are more resistant to antibiotics. So to identify that, there's a staining procedure where a dye is used, a crystal violet stain dye is used, and based on that dye, it will give the gram positive bacteria will give a purple color, will retain the purple color of the dye, whereas the gram negative bacteria won't retain it. So some few examples of the gram positive bacteria and gram negative bacteria are given in this slide. Like E. coli and Salmonella, they come in under gram negative bacteria, whereas Staphylococcus, Streptococcus, this bacteria come under gram positive bacteria. And the reason why they are different is because of their cell structure. The gram positive bacteria have a very thick peptidoglycan layer. Okay, and this peptidoglycan layer retains the purple color while experiment, whereas the gram negative bacteria has a thin peptidoglycan layer, and which is surrounded by a lipopolysaccharide uh, lipopolysaccharide membrane. So this is the procedure of gram staining. That first a primary strain like crystal violet stain is done. Then iodine is used. Iodine is used as a mordant because it will form a complex with it and will retain the color. But then again, alcohol is used over it. So alcohol will uh, remove the color, will try to decolorize it. And again, the safranin, that is the counter stain, is given when, but the gram positive bacteria will retain this color, whereas the gram negative bacteria cannot retain this color when the discolorization is done, and it can be observed in under a microscope. If it is purple in color, that means it is gram positive bacteria, and if the purple color vanishes and just a reddish or pink red color or pink color appears, that means it is a gram negative bacteria. So this is gram staining. This is the procedure is explained in the image. Next is serial dilution. Actually, bacteria or microorganism, they multiply very fast, and they are present in a higher number of uh, amount, like 10,000 log cycle, or 10 to the power 6 log cycle, 12 log cycles. So that is why when we do plating of those bacteria, we need a serial dilution method, so that in diluted form we can count the number of colonies, because a petri dish is of smaller size, or whatever plating tubes or petri dishes are of smaller size. Therefore, serial dilution method is used. So what is done? It is being diluted with water. The actual broth or the actual media is being diluted with water. So various number of dilution is done. So at the end, after plating, when the dilution is done, do whatever steps necessary after plating, again when we get the microorganism growth, we use this formula to calculate the calculate the actual amount of colonies. Okay, CFU, colony forming units. So the formula for colony forming units is number of colonies, then the dilution factor, whatever dilution factor we have used, and the volume we have used while plating. Therefore, in this method, by this method, you can easily find what will be your dilution factor. Because suppose if you have done the first dilution, it is 1:10. That means 10 to the power minus 1. Then again, the second dilution, when you take 1 ml and put it in again in a 9 ml of water, it becomes again the second dilution is to the power 100. Then the third dilution is to the power 1000. So in this manner, it is done. Suppose till the last step, if you have done till 10 to the power 4, then you can keep your dilution factors as 10 to the power minus 4. Okay. And this is also one of the important thing where used is the selection of media. Suppose or the microorganism have some selective media, like yeast and mold, they grow in potato dextrose agar. So this kind of bacteria, also few bacteria related to food have their common media. Like if it is a liquid medium, it is known as broth, and if it is a solid medium, it is known as agar. So like for staphylococcus, it is milk agar, and the very common is EMB agar, yeah, eosin methylene blue agar, used for E. coli. Then our mannitol agar, used for staphylococcus aureus. So then EMB agar, eosin methylene blue agar, is again used for aerobacter. Okay, so if your bacteria belongs to this group, so your microorganism belongs to this particular group, you have to have some selective agar while plating them or while growing them. So thank you for listening to this topic.